Having talked about electric fields now, I want to talk a little bit about what electric fields do to conductors. Specifically, let's imagine having an electric field going through space. Okay. We'll make it uniform. All right. There's lots of ways to do this, by the way. One way would be to have a bunch of positive charge plates, or have a positively charged plate over here. Okay. And a negatively charged plate over here. As I said in the last video, a sheet of infinite positive charge has a uniform field going away from it. A sheet of uniform negative charge has the same basic thing but towards it. So in between you get a nice uniform field. This is the way we actually do this in the lab. Now imagine sticking some kind of conductor in the middle. Okay? We'll just drop a piece of, I don't know, gold. Okay? We'll be extravagant on this. Now what's going to happen here? Well, the nice thing about conductors is charges are free to move. Now, if your charges are free to move, and we'll forget the fact that we know electrons are the only things that are moving most of the time, and just pretend like both positive and negative charges can move around. And that's effectively what looks like happening anyway. So the positive charges are going to start migrating with the field direction, because that's what the field direction tells us. We're going to start building up positive charges on this end of the conductor. Okay? Meanwhile, the negative charges have the exact reverse effect. They want to go to the left. So they're going to build up on the other side of the conductor. Now, a fair question to ask ourselves is, how long will they keep building up? I mean, so we start getting some charges moving right, some charges moving left. When will that stop? Well, as long as there's any field inside the conductor at all, okay, they're going to have reason to keep moving. So when will this stop? As soon as the field inside the conductor goes away, okay? So the field inside a conductor tends to be 0, okay? So I'm just going to erase my field here as best I can. All right. The charges move to basically cancel the field out, removing any field at all. There are limitations on this. The big one that we're going to encounter later on in the term is if you keep basically replacing the field. You have a circuit and some metal conductors, some wires running from one end of a battery to another. The battery creates an electric field inside the wire. Now, the charges move to try to cancel that out, but the battery is constantly basically replacing the field. The charges move, and then the battery just basically generates another field again. But if you're not doing that, if you don't have a constant source to basically replace the field, the charges will move until you've got no field inside the conductor, which is a really, really cool property. All right, that's all I have for today. I will see everybody in class.